We should start. Yeah.
Okay. So I invite you to share this and make yourself at home, let me say.
So I don't know if you can see the screen.
Yes.
You can see.
Yes.
Okay. Just
Zanetta, can you share and moderate the workshop?
Sorry?
Can you moderate and share the workshop?
Of course, of course.
Okay, so I switch off I unmute myself.
So, welcome to our mutual learning workshop with the main focus of energy planning models. And as you already see, our first presentation will bring closer the subject of Green Deal and climate energy targets. I give the floor to Dr. Pio Lombardi from Fraunhofer Institute.
Dziękuję, Zaneta. Just the one question. You see the enlarged version or the short version of presentation? Because I'm using 3 monitors now.
No, we don't see the presentation mode.
Okay, you don't
the
see
original
it.
PowerPoint.
Okay, I tried to solve the problem just some seconds more. Oh no, maybe this one.
No, this one is not good.
Yeah.
This is the present. Now you are in the presenter view.
Now it should work.
Yeah.
Yes.
Okay. So, okay. So thank you to everybody. Good morning to everybody. I would like to give you some overview on what will be the energy system in the futures. So as you know, in Europe we have a new strategy, energy strategy, which is called the Green Deal, and it will, in my point of view, make a revolution of the energy system, and not only of energy system, but also of our European society. Why? Because we aim to decarbonize not only the energy production, but also our economy. So, Green Deal is something that you maybe already know what is. It's the new European strategy for making the economy and the society, European society, more sustainable, which means that we should try to decrease, to neutralize our emission of CO2 equivalent is better, and using mostly renewable energies. Now, what I have done, I tried to review different scientific papers, and I tried to depict how will be the system in the future. Before to show you the next slides, I would like to see you in graphic way what the Green Deal means. So you know that, if I well remember, 12 years ago, we have had a new strategy, which was European 2020, which aimed by 2020, for this year, to decrease of 20% the CO2 emission compared to the emission to 1990, to increase of 20% of the energy efficiency, and to integrate in the energy system 20% of renewables. So 2020 is not yet finished. Just we have the information of 2018. By 2018, the reduction of CO2 were about 23%. So we have already achieved the target related to CO2 emissions. By 2018, the generation from renewables could cover 18.9% of the total energy generation. So as far as I know, it will be not achieve the target 2020 because we will not be able to increase from 18.9 to 20% by 2020. This information was given before COVID. So now maybe because of COVID situation, since the load is decreased, I can imagine that we will achieve also the target 20% of less integration into the energy system. As you see in the diagram, we have also some very important information. The diagram depicts how the CO2 profile from 1990 to 2018. It is the orange curve. You see that more or less it is decreased about 23%. And on the same time, the GDP, so the economy of the European, is increased or about 63% more. So we were able to create new economy using lesser fossil sources. This is the key message of this diagram. So this is the status what we have today, more or less. Before to come to 2050, we have some kind of intermediate targets, which is the 2030. By 2030, the target aims to decrease by 55% the CO2 equivalent compared to 1990. So how you can achieve this target? Mostly by increasing the renewable integration of 32%, by decreasing the CO2 using the emission trading scheme, the sharing regulation, the land use forestry and regulation of 40%, and increasing the energy efficiency of 32.5%. So using all these actions to be able to decrease the CO2 emission of 55%. By 2050, the aim is to decarbonize the system using only renewable energy sources or energy sources which have been converted from electricity generated by renewables. So, as I said to you before, I try to review different papers, different reports about how the scientific community sees such scenario. So, actually, there is not just one scenario which depicts how Europe will be in 2050.
Excuse me, can all people turn off the microphones? Thank you.
So there is not just one strategy, or there is not just one vision which depicts the Europe by in 2050. But the scientific community suggests that we will have more offshore wind farms. We will definitively use more photovoltaic panels. We need some kind of European supergrid, and we will install more energy storage system like battery or like electric vehicles, which are as mobile storage system. And we will use the natural gas infrastructure, what we have already today, which means pipelines, which means compressor, which means caverns. But instead to transfer natural gas, we will feed the natural gas infrastructure using hydrogen or methane, so green methane, or a mixture between hydrogen and methane. So they are the key strategy or the key technologies which the scientific community agrees that we will need in the coming years. So, as you see, wind farm, we will have mostly new offshore wind farms. On onshore side, so the potential to install onshore new wind farm park is not so high. So on onshore, we will have the repower, so we can install more efficient or bigger wind turbines, but mostly of the electricity, wind energy will be installed on offshore. So you see here, it comes from the Wind European Association. It depicts how Europe will install the new wind turbines. They estimate that by 2050, it will be installed about 450 gigawatt. Just to have some benchmark, in Germany we have more or less 50 gigawatt of installed wind turbine. So we need something which is 9 times higher what we have in Germany. And most of this wind turbine will be installed on the North Sea. So North Sea will supply UK, will supply Belgium, Netherlands, Germany, Denmark, and Norway. A part of the other part of wind turbine will be installed on Atlantic Ocean and the Baltic Sea, which will supply Poland, Lithuania, Finland, and Sweden, as well as Ireland, and partially also France. And a few parts of this 70 gigawatt will install on Mediterranean Sea, supplying France, Spain mostly. You see here how much wind turbine or wind farms capacity we need to install every year in order to achieve the target of 450 gigawatt by 2050. So it is something that we need to install offshore about 5 to 10 up to 20 gigawatt of offshore wind turbine, which is not easy because the technology seems similar to the onshore technology, but it's not the same. And mostly it's not easy because we need to create new grids on the sea, which transport the power to the land. But we will see later how to do it. So the second technology offshore, of course, will be the photovoltaic. You see here some results coming from this paper. So the role of storage technology for the transition of 100% renewable energy system in Europe. They have analyzed two scenarios. On the right part, it is the optimized scenario, and here on the left part is not the optimized scenario. What does it mean? In the right part, the optimized scenario forecasted that between areas, between nations, there is interconnections. So there is new power lines which interconnect one region to another region. Doing that, you see that we need lesser installed capacity if we compare with a strategy in which everybody apply or plan its action. We have to see if the neighboring land can help him in the transmission of the power. Anyway, you see here that the photovoltaic, they will contribute massively on the power generation. It's sometimes of something like 1,000 gigawatt of photovoltaic power, which is a very huge number. Anyway, it has been estimated that there is enough space for installing such amount of power. What is important in this study, they don't consider the Desertec scenario. I don't know if you know the Desertec scenario, which has been developed some years ago. The Desertec scenario considers the Sahara Desert or the North African lands as region in which to install photovoltaic and solar thermal collectors for producing electricity, of course. This scenario, what I'm depicting, is not considered that option. So the power, the electric power is generated in Europe and is consumed in Europe. So another technology that we need is for sure the energy storage system. We will generate electricity using volatile sources like wind, like solar, but in order to compensate such a volatility, we need storage system. And you see here, we have different kinds of storage technology, like battery, like pumped hydro, like adiabatic compressed air storage system, gas, and heat storage. So related to the pumped hydro, in Europe, there is not so much potential. So also the acceptance to install a new pumped hydro storage system is very low. So what we can use now is what has been installed 20, 30 years ago. Case system, so diabatic compressed storage system, we have in Europe one diabatic, so not adiabatic, which works since more than 40 years in Germany, which stores electricity in form of compressed air, and then the compressed air is stored inside cavern. So the adiabatic version considers not only the compression of air, but also on the thermal storage system, which can be used for heating the compressed air, and then to feed and gas turbine, so air, compressed air turbine for generating electricity. Anyway, it is a technology which allows to store a lot of energy and which can be used also for grid supporting. Gas storage, we have a lot of caverns. At the moment, we have many million of cubic meter of caverns in which the natural gas coming from Russia, coming from North Africa, is stored during the summertime for covering the peak in the winter time. So we can use such infrastructure, the caverns, we can use the pipelines of the natural gas for storing hydrogen and storing methane, which can be produced by hydrogen and CO2, and therefore to save investment money. And its storage, of course, the system will use no more gas-fired boilers. So the vision is to have heat pumps, electric-driven heat pumps. In order to efficiently drive electric-driven heat pumps, you need heat storage system. So heat storage will also contribute to integrate the volatility of the system. So this is the idea. The grid that the super grid that we will have in Europe. So you see, this grid will connect all the offshore wind farms to the land. And the power, and you see that all Europe will be mostly connected as a one meshed grid, in which from north to south, from west to east, the power will be transferred. In order to do that, it's important. So the key message that I want to send you, that is the acceptance to have new infrastructure like power transfer line is not so high. So what we need is we need to better communicate to the population that such kind of infrastructure is mandatory. We need it if we want to decarbonize the system. Otherwise, it will be not possible to generate so much. So 1,000 gigawatt of photovoltaic, 450 gigawatt of wind will be not possible to integrate into our system. So this is the part which is more technical. The part which is more, I would say, not so interesting from my point of view is how the Green Deal will support such a vision. So we will have some kind of 1 trillion euro as budget for supporting the energy generation from renewable to energy efficiency, the energy storage, and so on. So it's a lot of money. Anyway, I don't think it is enough, because in some study that I have read, we need since today to invest about 500 billion euro every year in order to, if you want to have a decarbonized system. So 500 billion euro since now till 2050 if we want to decarbonize it. So anyway, this is just one part of such a money that we need to invest. And from the research funding program, of course, we will have the extension of the Horizon 2020, which will be the Green Deal call, and will support the research on decarbonization of the system. And this is the last slide. So I don't know if you have any question. So what I want to point out, and one last point, is We have, similar to the grid that you see here, we have also a network of natural gas, which we already use since many years. We may avoid to install new electric power grid if we convert electricity into hydrogen or into methane, and then we can use the pipeline that we already have. But doing that, from one side, will increase the acceptance because we don't need to install a lot of lines like in this diagram this picture is depicted. But converting electricity into gas and then gas into electricity is not a very efficient solution, because we have a lot of losses. So just to have an idea, if I have 1 kilowatt-hour of electricity generated by sun, and I converted it into hydrogen, and then hydrogen I converted it into methane using CO2, and then I use methane for producing electricity again. So I have at the beginning 1 kilowatt-hour. At the end, I will be able to generate 0.2, 0.3 kilowatt-hour of electricity because I have a lot of losses with the today technology. So for one side, allow to not install a lot of power lines, if I make the power to gas for hydrogen. But from the other side, the efficiency is not so high as we had if we transfer directly electricity from one point to another point. But it could be an option in some cases. So I hope that I could depict you the overview of the system.
Here, one more question from Matteo. And did you take into account also the new demand of energy from electrical mobility, for instance, in these scenarios?
The study that I have reviewed consider not only the electric load that we have today, they have the transportation load, they have also the heating load, which is today covered by natural gas. So in order to cover all these loads, you need to install a lot of, so the number that I have given you, or they have simulated, they have done the analysis, like this one. This is interesting, yeah? So we talk about a total of 2.7 gigawatt new installed capacity. You see here, we will still have some kind of steam turbine. We still have some kind of gas turbine. If they are driven by the methane that we convert from electricity, from renewable electricity. So such technology like gas turbine, open cycle or combined gas turbine, they will be technology that we still will need in 2050 for compensating the volatility of renewable. Because a gas turbine is a technology that is able to produce in a short time the power that you need for covering the load or for balancing the volatility of wind or of the sun. So such kind of technology we will use, but they will not be driven from natural gas coming from Russia or coming from North Africa. The gas will be methane, only methane, that can be converted from electricity using the Sabatier process, for example.
But transportation is included in this scenario, or there are only stationary loads?
No, it's included.
It is included, okay.
This year is already included. So you see that where it will be generated and where it will be transported.
No, but not transportation of electricity, but
the mobility. It's considered, yes.
Okay, thank you.
So, but what is important is if you see the analysis of the results, you may find other studies that they have different results, what I have already found. Everything, so the results always depends on the assumption that you have done in your model. So maybe in another one you will find higher installed capacity that we need. In other, we will find lower capacity that we need. Others will consider the more efficient batteries, so not with lithium-ion, but maybe with another technology which are more efficient. So we talk about a lot of different thousand gigawatt of new installed capacity. This is, I think that it's okay. If there will be 2,000 or 3,000, it's not easy now to say.
Thank you very much, Pio.
And show you the strategy which has been implemented in Saxony Anhalt for the energy strategy. Yes. So at the moment there is one strategy which is called CEC, Climate and Energy Concept, which is already implemented and is used. And the second strategy, which is in this day going to be developed, is the hydrogen strategy. So I will give you some short description of the both strategies. The CEC strategy aimed to decrease the carbon, the CO2 equivalent emission in the region Saxony Anhalt to 31.3 million tons, which is million tons. So the aim was in using renewables and using storing renewable energies in the region in order to supply the load in the region of Saxony Anhalt. For the CEC strategy have been identified 5 groups, measurement groups, and 71 measures which will affect on this CO2 reduction. The strategy has been done together with private and public stakeholders, together with research centers and university, which have given the scientific support. So on the first measurement group, Group A, which is called energy sector, just 2 examples here. From one side, in the Saxony Anhalt, we have a Saxony Anhalt energy program, which aims to more efficient the local enterprises, and therefore support economically the enterprise to change the old motor, for example, to use more efficient motor, or to digitalize the processes in order to better coordinate the loads. This program is supported by EDF. EDF will also support next period the conversion of electricity from renewable into hydrogen. But at this point, I will come back later. So just add an example in the measurement A. From one side, the aim is to increase the power generated by renewables, namely by wind. Saxony Anhalt is a very windy region. At the moment, there are about 5.6 gigawatt installed wind park. So the idea is to extend using the repowering concept in 2020, 150 megawatt more of wind park, which means about 1,070,000 tons of CO2 equivalent reduction. Not only wind, Saxony Anhalt, we have also sun sometimes. So we have also implemented programs which aim support to private person to use sun energy in the house. So the idea is the self-consumption. Therefore, we have the program photovoltaic on the roof, which combines photovoltaic and storage system, because the best idea is that you don't feed the network, because in Germany, the German network is already stressed by renewables. So the idea is we have your photovoltaic in your home, and you charge your battery storage using the power that you generate by your photovoltaic. And therefore, there is the program Measurement B26, which aim to support such kind of project. Not only for private, I would say, project. The idea is by 2020 to extend the installation of photovoltaic by 244 megawatt. And you see also the amount of CO2 equivalent which is target to achieve by 2020. So the generation, then we have the transportation. On the transportation side, there are mostly two, so example, there are two initiatives. One is to build new roads, bicycle roads. The second, to move, to convince the private person to leave their own car and they used to use public means or public transportation. If you do that, you may have some economic incentive when you declare your tax at the end of the year. This is one initiative which is going to be implemented in the coming months. So on the group D, we have the economies which this initiative supports the companies to better use their resources, in this case it's water, and to promote the circular economy approach. So to reuse what is your waste. And so in this case, it's also an energy efficiency process and reuse or utilization of mineral waste. On group E, agriculture and food, the idea of the measurement target on to better use the resources coming from forestry for energetic purposes, but not only that, the measurement aims to better protect climate, I would say, zones which are particularly important for the vegetation or for the animals which live in that region. So this is for the CAC strategy. As I said, these days, Martin Stutze is now in this moment working on the hydrogen strategy. We also aim to develop a strategy which promotes the hydrogen. Why that? Because Saxony Anhalt is a windly region, so we have a lot of renewables. It is an energy exporter region, which means we are not able to integrate in our system the power that we generate, and we export to the neighboring countries or lands like Lower Saxony or Brandenburg and so on. We don't have a lot of pump hydro storage system. We have just two pump hydro storage system. We have a lot of caverns. So the idea is to convert hydrogen, electricity into hydrogen, and to use the hydrogen infrastructure, which is we have here in Saxony Anhalt, different kilometers of hydrogen pipelines, but not only the hydrogen pipelines, also the natural gas pipeline. So for that, we have some targets. For example, we want to install by 2030 1 gigawatt of electrolyzer. The electrolyzer is the equipment which allows to transform electricity into hydrogen, and to additionally install 5 gigawatt, so what we have today, more or less, and extend the H2, so hydrogen grid. Of course, by 2030, we want to still further decarbonize our region. So I tried to do as short as I could. So if you have any question, maybe now or later, or we can talk privately after the meeting.
No, thank you from my side for your very quick presentation. I'm sorry for that, because I think there were a lot of very interesting information in. I think we have some questions, so maybe we can use additional 5 minutes for this.
Yeah. We have time.
I don't know if anyone wants to point out any question. For my side, I would like to clarify a little bit what can be the role of Prospect 2030 in the strategy already developed or to be updated. I don't know. So if you can just clarify this, what will be the input of our project in this policy framework of the ministry?
Okay. As one of the target of project is the leverage effect, as you said. On that, we have already spoken with Martin, with Müller, which is the Ministerium for Environment and Energy, in order to try to advise on which action should be better planned or better considered. Of course, we have some step before than prospect, because we started with KEC 2 years ago. As I said here, in KEC, we also advise the Ministerium which strategy we should use for the decarbonize system. So the role of prospect may be that we can make more robust the decision that we go to advise, which will come from prospect.
Okay. And from content point of view, I can see that your okay, the region is having a specific strategy on hydrogen. I think this is interesting. And what about the security issues? Is this something that is taken, or it's from technical point of view already solved, or it is an issue to store hydrogen? I mean, or to I'm not very an expert on the topic. But,
So, actually, from the physical point of view, there are no problems if you mix hydrogen with natural gas. Up to 5% of volumetric concentration. So there are a lot of analysis, there are a lot of research which demonstrated that a mixture of hydrogen and natural gas up to 5% of hydrogen works very well without any problem. Of course, to store hydrogen should be use different technology than storing natural gas. Up to now, there are not a lot of problems on it. So there are different kinds of technology, storing technology. You can store as solid, you can store as liquid, you can store as gas. Hydrogen, there are a lot of possibility to store hydrogen. So about the problem, I don't see a lot of problems using hydrogen. So if we make a new infrastructure for hydrogen, there are for sure no problems. If you use the infrastructure that we have already now, which was designed for natural gas, of course, then you may have problems. So in that case, therefore, I said if you mix up to 5% hydrogen and natural gas, it still works good. If you want to increase the concentration of hydrogen, then maybe a lot of problems. So, yeah.
thank you very much. Thank you very much.